That's one of the great things about live broadcasting is that you can actually go back and say bloppers, bloppers, bloppers. Okay, good afternoon, good evening. Welcome to the MLflow AMA. My name is Jules Damji, and I'm the developer advocate here at Databricks. Today, we actually have a panel of experts from various fields across the industry. I've got Manny Parquet, who is the staff engineer in the MLflow team, and he has been working on a model registry as well as most recently on the FeatureStore. We got Clemens Melwell. You saw him fishing today on the lake house. He's the head of ML products, and glad to have us here. And then we have Corey Zumar, who is the senior engineer at MLflow engineering team, and he's got his fingerprints all over the MLflow code. Most recently, he has been concentrating on making tracking API a lot easier, particularly in MLflow autologging. And then we got Joseph Bradley. He's an all-time tenure, probably has got the most senior tenure here, being at Databricks, probably 6 + 7 years. He used to be an ML computer engineer for Apache Spark, and more recently now he's helping customers really concentrate on how to solve their tough problems with ML platform. So welcome you all. Thanks for taking the time and being here today. So I'm going to ask the first question today. We announced a plethora of ML products this morning, especially the Databricks machine learning, which some would argue that it actually helps us aid and augment the MLOps lifecycle. Now, generally, people would say MLOps is the function of MLOps is really to reduce the friction to get the model from idea to production, and also with minimal amount of risk. How do you all of you, any of you, think that the new Databricks ML platform that we actually announced today addresses or reduces the friction or reduces the risk in getting model to production? Anyone want to take a shot at that?
I mean, maybe I can do the first attempt at this.
Yes, please.
And I mentioned this briefly in the keynote. I think one of the ways that this actually materializes in the product is actually the way that we can actually provide reproducibility. And what I mean by this is we have a data native platform where we can really integrate from raw data, how these data are being transformed, how they feed into the machine learning models, how you track experimentation, how you manage the model deployment lifecycle, the model deployment itself. And because we provide all of these different capabilities, we can integrate them really well, and like we can simplify that workflow, and we can make sure that there's no cliffs in between these steps. Of course, Databricks is an open platform, so we have entry points all along the way, right? For all we care, you can train a machine learning model on your laptop and bring it to Databricks to manage in the model registry. But for the end-to-end workflow, we can really make sure that it's well integrated and provides all of the best practices, all the way, as mentioned, from raw data to model deployment, which is quite unique in the market.
So in terms of, you mentioned about it actually introduces or allows us to have the best practices. If you were to enumerate 3 best practices, what would those be?
Well, I'll let the others also add to this, but I think the key thing that I also said in my slides was that MLOps for me is really the combination of data ops, DevOps, and model ops.
Right.
And if you want to tie that to best practices, you need to make sure that like your data is governed correctly, and like you have lineage information of what data is being used in what machine learning models. Of course, you need to make sure that your code is versioned. and governed correctly. And then machine learning models also need to be managed as production assets and the lifecycle. And really bringing all of these three together is, to me, what MLOps is. And there's best practices in each one of these areas.
So in other words, this also sort of mitigates the risk that I talked about, because people talk about risk, and risk could be, the model could go awry, you're not monitoring the model, or somebody else can without authorization deploy the model in the field. Now, talking about field, Joseph, you've been actually helping a lot of customers today, and we hear about MLOps generally as this new discipline in its very infancy stage, and it's very data-centric, and it's very code-centric. And we've seen this practice before, where we have seen this software engineering around ops and dev as well. How much do you think these software engineering practices translate very easily to ML? And do you think we have to reinvent the wheel, or we can actually borrow a lot from the ops and dev? What has been your encounter with the customers, and how are they actually handling these new way of doing ML ops in general?
For sure. Yeah, I actually wanted to say or answer a similar thing to the previous question about best practices, where, yeah, there's a long time practice in software development of, proper ops, DevOps, development practices, whether you subscribe to like Agile or Scrum or, all of these different practices around it. I think that a lot of these do translate to the ML space. Now, the skill sets, of course, do end up being different. You may not need to know much about statistics to do other parts of software engineering, but maybe that'll be important for ML. But I think a lot of the practices, going from dev to staging to production, having automation in place for checks, but also having humans in the loop where needed. A lot of these practices do carry over. And I do think a big thing which has been missing has been structure. For software development, there's GitHub or other Git providers. There are also tools for CICD. I think there have been a lot missing in the ML space, and I'm pretty excited about all of the Databricks ML announcements, because I think they add a lot of that structure needed for those existing kind of ops practices people know about.
And what is some of the things that the structure that for example, say MLflow addresses? Are you talking about when we move a model from say one stage to the other one? Is that the structure you're talking about? Is that the aspect of how to manage a CIDC in that area?
Exactly. Like the same way you move code towards production or data towards production, similarly need structure in place, meaning, a place to store models, permissions on top of that, APIs for working with this service, providing that structure. And I think that MLflow and its model registry, for example, do a lot in providing that.
I mean, the other thing we actually announced today was the FeatureStore, and it was one of the components that was actually missing quite a bit in managing the features. And people would say, well, model registry allows you the ability to version your model versions from idea to production, and FeatureStore allows you to do ML feature versioning. So perhaps I'll pose that question to Manny, since you've been leading the efforts in this particular area, and this is an exciting new offering that we actually announced today. What were the design principles that drove the FeatureStore's architecture, and what do we expect next? I mean, yes, we've got the private or public preview or private preview. What's the next? First, tell me what actually drove the design principle, and what do we expect more from the FeatureStore?
Yeah, that's a very good question. So here's connecting it to your previous question, where you said what are the advantages of having an ML system, is that your data scientists, your data engineers want a lot of flexibility in the way they create the features, they create the models, what packages they want to use, what libraries they would like to use, and how they would create the model, right? But there are other things that sort of govern the security of or who can access these things. That there aren't too many things. Like for example, there might be a single sign-on that is needed. That having an ability to sort of control all of the different assets, whether they are features or models or serving endpoints, under a common mechanism that you can easily traverse from one to the other and have that journey go through is sort of what sort of brings this ML platform together. As far as the feature store is, you want to sort of build on some of these components and principles that we've used for MLflow, right? That we wanted to sort of build things that were API first, that the users have flexibility in the way they define their features, the way they use features in models, and the ability to sort of track those feature usages across the different components within Databricks, that we that a feature is used within this model, and be able to sort of see that. A lot of us use feature stores and build feature stores. We first went to the customers to sort of ask them, what are the things, what are your pain points that that you want us to address with a product like this, right? And the thing that we kept hearing was shareability, discoverability of features, so that they are not recreated all the time. I need to know how they are sort of done, and ability to have a good security model around them, and then a mechanism to sort of trace the feature through the entire system, which data is used, where it is the feature is being used, and who are using it, and so on and so forth. So having a mechanism where you build the features through a simple API, and then so effectively just two principles, right? To have it such that it's simple API, and then it ties out to all of these things. And I guess there's one more, is that it should be able to build on components that already exist, and extensibility to other frameworks and stuff like that. So I guess the three principles, but I'm a software engineer, so I can be off by one.
But do you think the feature stores, as Clemens pointed out today, solves two problems? One is that it mitigates the offline and the online skewing, and the second thing, as you alluded to, the fact that it gives you the ability to discover the features that other people have actually developed. But do you really think that people who are building models might be able to reuse the feature? Do you think, like, I can reuse somebody who created a feature for a deep learning model? Would I be able to use that feature for some classification? Or this is more specific to, say, recommendation engines or regression, where certain models may share certain aspects of a customer, or may share certain aspects of the customer behavior? Or is it possible that all these features can be shared by a lot of models who try to solve the same problem?
Yeah, I mean, features are aggregated data, right? Or they could be coming in from the specific request for which you need to find a prediction, right? So whether the feature is an aggregated data and you're using it in a random forest or scikit-learn model, or using it as input into a decision, into a network, right? That it's input that has been curated, that is a pipeline that is scheduled, that is running every day, and then you can sort of use that to sort of see that. So you can use your features for the purposes of any sort of a model that could be generic. You could use an existing features table and fork it out and say that I want to sort of create a feature table that looks like this, but I want to change the logic, the way I'm computing it. I'm adding new features. And you can use it for your other dashboarding and BI use cases as well. Right? So this is sort of comes down to the magic of sort of building components that are reusable and can be used in different contexts, and sort of features that are used for machine learning can also be used for dashboarding.
Brilliant. Now, I think a related question that actually came up from the audience, especially dealing with features online and doing serving. What is the plan for ML serving? Clemens mentioned about being able to deploy, and we saw the AutoML example, and we saw Casey give a demo about serving models right in real time on the Databricks platform. But what is the plan for ML serving? The current approach works, but it's not fit for the enterprise. Ideally, we would have to have this backed up on the Kubernetes and a load balance. For now, it is a great solution for sort of a quick API development, but ideally, we would have more options to control the compute and scale. Do we actually have plans to make this available sometime soon, or are you guys looking into it?
Yeah, so I can maybe address that on a high level. So first maybe to clarify the question, we have a lot of enterprises using the product, right? So I think it's not necessarily the type of company using it. It's mostly related to the use case and the attributes of the workloads that you expect for firming, right? So the current product, I think will scale to about 30 QPS, and it's based on a database cluster, right? So it has the availability property of a database cluster. We are heavily investing in that area and will, over time, slowly release some of these constraints and make sure that the product can support bigger scale and more stringent availability requirements. And I think people should watch out for announcements and new product development that may later this year have a step function in terms of some of the attributes that I mentioned in that question.
Now, one of the things, just to sort of move more towards developer APIs, one of the things that Matej mentioned about some of the new things that we have actually done, and something quite striking. A lot of people that when I teach workshops, I get the idea, and I get this aha moment from people who start using the APIs. And I think this question is more fitting for Corey, who has been working on the APIs for autologging. The question that I get normally from the panel or from the field or from the workshops is that when should I use MLflow autologging, and when should I? Are there any best practices towards that? Or what are the advantages of using MLflow autologging? And what about if I have additional metrics which are not computed by autologging that I want to log as part of the autologging? How do I go about doing that, Corey?
It's an excellent question, Jules. Just so for some added context, we're working on simplifying the experimentation and experiment tracking procedure offered in both open source MLflow and on Databricks. And so auto-logging is a critical component to ensuring that regardless of what model you're training and where you're training it, you have this reliable and consistent baseline of information, including lineage, parameters, metrics, and files for that training, so that later on, when you need to audit model performance or move the model into staging and production environments, there's a strong track record of exactly where that model came from. And obviously, with the wide variety of ML frameworks that are available and all the different training techniques that are used, it's difficult to build a one-size-fits-all solution that captures absolutely every piece of information for every single use case. So while that baseline is really important and it's critical to have in all use cases, we recognize that many ML practitioners need to add their own custom lineage info, parameters, and metrics. And so the two are designed to play nicely together.
Okay, so in other words, go ahead.
Go ahead.
So in other words, if I'm using, say, MLflow autologging for PyTorch Lightning, and then I have additional caps and metrics that I'm computing, although we capture those, I could actually use the tracking API to log those in addition to what AutoML would capture, correct?
You got it. Yep. And it speaks to the sort of extensibility and customizability of all the components offered on the ML platform and MLflow. So we build these with open APIs that can be extended to a variety of infrastructure and use cases, and tracking is no exception there.
Just switching gears a little bit to more sort of field engineering, because I know Joseph has been concentrating a lot on those. Joseph, do you have any best practice guidance for a single deployment of MLflow? Ideally, customers want a single version which transcends all the environments. A separate workspace is one option, but is that the best practice, or should we deeply just use open source for MLflow on Kubernetes? Or what has been your sort of field experience in that aspect?
For sure. I think that MLflow's openness has been really important for most customers I've worked with, where plenty, will want to develop in their own IDE on their laptop. And there it's important that they be able to maybe, do some quick, implement unit tests, for example, which run against a local MLflow server, which is just started on their laptop. But I think that especially with larger organizations where it's not just a couple people working with MLflow, it's really valuable to have a more centralized service, such as a centralized model registry, which works across multiple workspaces from dev to staging to prod, with multiple teams, fitting into existing access control mechanisms, their identity provider, all of that. And for most customers, like that area is not their forte, and it doesn't make sense to waste time building it. So it's like very valuable to have a managed service there.
Now, the other thing, incidentally, this evening, we're actually having Clement, the co-creator of Hugging Face, at a meetup today. He's going to be talking about transformers. And I was looking through the MLflow built-in libraries, and currently we don't have that Hugging Face. But if I actually wanted to use MLflow with Hugging Face, how would I actually go about using it?
I suppose I can go ahead and step in there.
I was going to put you on the spot there because we sort of built in all these old models. I know we have the support for TensorFlow based transformers, but we don't have the core support for the Hugging Face. So go ahead, Corey.
Absolutely. Yeah, so it depends on what the goal is. The MLflow platform in general offers all the components that are necessary to integrate with any ML framework. We just happen to provide first-class support for a certain set of frameworks like scikit-learn, PyTorch, TensorFlow, and others. But each of these APIs, for example, tracking, can be used to log the parameters and the metrics and other information for a Hugging Face model just as easily as they could be for scikit-learn or TensorFlow. We can additionally define a model format for Hugging Face models that integrates natively with the MLflow model specification, and we provide documentation and guidelines on how to do so. And then when it comes to model registration and deployments, that MLflow model format can then be translated into managed and versioned models, as well as inference endpoints and batch inference workloads. So as always, the MLflow platform can natively do these things regardless of ML framework. And we are also happy to accept contributions for APIs that are specific to Hugging Face for model serialization and auto logging.
Now, I was just perusing through the Hugging Face API on their website, and they do actually have an MLflow callback where you can actually log MLflow artifacts. So there is some form of integration, which was delightful for me to know about that. Okay, there's one question that's actually came in from the audience. He said, we are using PySpark NLP to transform text fill into TF-DI score norm. Then we use PySpark to use the FM classifier to train the model. Could you use MLflow and pipeline in the NLP and ML to serve REST API interface?
I guess, go ahead, Joseph.
I think we'd say a similar thing. The easy answer is yes. MLflow does have built-in support for custom models and also custom logic around models. So even if, say, MLflow supports out of the box, like logging one model type in your pipeline, but you need to add on additional pre-processing, post-processing logic, tie multiple models together, et cetera. MLflow is able to wrap those things up into model artifacts. And that, makes it pretty nice in terms of having that abstraction for then kind of identical ways of moving such models towards production.
And the other question is, how does the newly announced AutoML will work with MLflow? Clemens, do you want to answer that?
So I think, so for AutoML, there's two different components, and right now, at least, it's limited to managed MLflow on Databricks, right? The one component is really what performs the model search, right? Basically that says, here is the API, and here's the data, and we are going to search across different models. That right now is independent of MLflow because it's a hyperparameter tuning exercise, if you will, with model type and architecture as the one key parameter. But everything, of course, that's related to tracking of those experiments and runs, tracking the code that produces them, right? Tracking the metrics and deploying the models is all native MLflow, right? So once the AutoML run is complete, it's just an MLflow experiment that has runs with like model type, hyperparameters, the model artifacts themselves, and then the model deployment lifecycle works natively. In the UI, and like some of you may have seen this, the MLflow experiment page actually adjusts itself if it's an AutoML run. So like it shows additional metadata. It shows like the AutoML workflow indicator, and it also links to the data preparation notebook. So it's basically like, if you will, a specialization and add-on to MLflow, and at least right now limited to the managed part.
Somebody's asking.
Go ahead.
Go ahead.
Want to add one thing which I'm excited about too, which is, a lot of people have been adopting MLflow. It's becoming more and more of a standard across platforms. But if you haven't, then you need to get started somehow. Another thing I really love about AutoML is that the generated notebooks include some MLflow logging code, and that's an easy way to generate examples about your specific data set of using MLflow tracking to get started. Right?
Absolutely, I think you touched on a very important point, and I like the adjective, the clear glass box, right? Because there's no black box; it's actually a clear glass. You can actually look at all the notebooks. You can go in and change the code, and we saw how Casey actually doing that. As a matter of fact, let me just see if there is a related question that somebody asked. How do you include a complete pipeline from transformation and inference into model registration? I don't know if I actually get the question right, but how do you actually include a complete pipeline transformation from inference all the way into model registration? I think he probably means by, how you're actually using the platform to do that.
Well, I'm actually going to, there's very specific APIs, right? So sklearn has a pipeline concept that can be wrapped up with the model itself. I think I would volunteer Corey to maybe comment on this, because maybe he's most familiar with those aspects.
Sure, absolutely. So as Clemens alluded to, there are multiple ways of looking at that. We can talk about pipelining the MLOps process and model development, or we can talk about sort of multi-stage pipeline models, which might be where this question is going. So as I mentioned previously, and Joseph also talked about in the context of another inference-related question, the MLflow model format is customizable. So there are certain types of pipelines like scikit-learn pipelines, and PySpark pipelines that are supported natively. You can take one of those, save it as an MLflow model, register it, and then deploy it. And the inference procedure will evaluate each stage of that pipeline and give you a result. But if you have a different sort of external pipeline that you'd like to expose as an MLflow model behind a REST endpoint or for batch scoring, you can express that pipeline logic using the model customization APIs and deploy it just as easily. And we have plenty of documentation about how to do that. So whether it's MLOps pipelining or inference pipelining, we have you covered.
There's another question about using the MLflow Python Spark UDF, where how do I load a keras model with the custom loss function using MLflow? Where do I specify the custom loss function during model loading? In other words, the person has built an MLflow model, but he actually wants to use a different loss function. Is it even possible?
So it's kind of a tricky conflating of context. One where we're talking about loss and training, and the other where we're talking about Spark UDFs, which are used as an inference tool. But what I can say is that with the MLflow model format, you can restore a model both as this generic Python function representation, which is fantastic for distributed inference with UDFs, or you can also reload that model as a native keras object and continue to retrain it. And that retraining can use any arbitrary parameters passed to the keras API, whether that's a custom loss function or other set of evaluation procedures. So yeah, it's kind of the best answer I can provide for that question.
Now, I think this question is probably more related to the FeatureStore, because people are really excited about this new offering. And can you actually use FeatureStore for deep learning models? Because normally there's no entity associated with the primary key of the features in order to do aggregation. How would you actually store the feature values for for say an image, and would you how would the tensors be represented? Would they be stored as a NumPy arrays? And if you actually wanted to get a feature from the online store, how would you actually fetch that without having an entity key? Do you have any insight for that, Manny?
Yeah, I can
Just a
try.
reminder, Manny, you have 40 seconds to answer this question.
Okay.
Yeah, we got 40. We got 40 seconds.
Cool. Let me use the remaining 32 seconds now. Is for deep learning, you could, like, right now we support the basic Spark types, but we're looking to add more types, like, arrays and other interesting things that we can sort of natively store. But if you are using deep learning algorithms for non-image things, then you can absolutely use any of the feature tables. The primary key is a mechanism of fetching features based on the transaction data that you're using to train your model. So yes, they all go hand in hand. They're sort of